Hi friends, my name is Zesha and I will provide some of the information about the light emitting diode, right? But before we go through the light emitting diode, uh, I will give you some of the information of the diodes, right? We know that there are the many types of diode, right, in electronics application, right? But generally, I use a PN junction diode and I will give you some of the information about the diode, right? First, we will go through the rectifier diode, right? Rectifier diode, which is a use for the rectification. So it is used as a low switching speed, as we know that, right? The next one is photodiode, which is convert a light energy into the electrical energy. Then the laser diode, which is used in the printers, CDs, and DVDs, even also in the medical application, right? The next one is tunnel diode, which is used in the oscillator and the microwave amplifier. Okay, and here we used some of the heavily doped PN junction diode. Okay, the next one is Zener diode. We know that Zener diode is used in the reverse bias condition, right? So it is useful for the voltage regulator or controller. Okay, the next one is vacuum diode and it is also used in the rectification. And the last, it is a Schottky diode. Schottky diode, we know that it is used for this fast switching. And now we are go through the light emitting diode. But we go through some of the basic. What is light, right? We know that in 1879, this Thomas Alva Edison, who's the first invented the incandescent light bulb. Okay, so the light is a types of the energy and it is released by the atom. Okay, so how can we how can we get the light? Because the light is made up of the small particles called photons, right? And photons have some of the energy and momentum, but there is a no mass. Okay, for example, we take the nucleus information. This is a nucleus, right? The electron is revolving around the nucleus. This is the second energy level, this is the third energy level. So we take this symbol like E1, E2 and E3. So this is the symbol of electrons. Okay, so the when the electrons orbiting very close to the nucleus, here we see that, right? This is the E1 energy level. When the electrons revolving around the near to the nucleus, right? It has a very low energy because it is can't escape from the nucleus or right and getting the high energy. The and the next one is E2 level. This is the E2 level which the electron have some of the high energy than the E1 level, right? And the last one is E3 level. In E3 level, electrons have some of the highest energy, so they can escape from the nucleus and get some of the energy and go through the low energy level because electrons are not only just stay for the long period in the high energy level, they came back to the came back to the ground level of energy level, right? This is around a very short period and it is around it like a nanosecond. In the nanosecond they come back to the ground level energy. Okay, but when the electron is going to the high energy level, when we apply some of the outside source, we have to apply some of the outside source, then the electron orbiting in the nucleus gains some of the energy and go through the high orbit, right? Or high energy level. Okay. Now, so we are go through, there are the three energy level bands. This is the most important for the behavior of the solids, right? There are the three energy bands: valence band, conduction band, and forbidden gap. Forbidden gap. Okay, this is the band energy diagram. Here we see that this is the valence band, which is also called the low energy level, right? So this is the conduction band. It is represented as a high energy level, and this is the forbidden gap, or we can call as a band gap. Okay, so the Band gap means it is the difference between the valence band and the conduction band. Okay, but here forbidden gap, which is the most probably or most major factor in the solid materials. Yes, we know that na, there are the classification of materials like insulator, conductor, and semiconductor. We know that the insulator have for high or high forbidden gap because there is a vast forbidden gap between the valence band and conduction band, so the electron can't move from the high energy level to the low energy level, right? And what is the phenomena of light emitting diode? The phenomena of light emitting diode it is when uh, when the electrons go through the high energy level to low energy level, they generate or they emit some of the photon in the terms of the energy, and we get the light emit, and it is used in the light emitting diode. But in insulator it is not possible, right? But yes, we can see in the conductors. Yes, conductors, which material have the there is a no forbidden gap. I mean, it means that the valence band and conduction band both are not separated. Both are just one of equal, right? So the electrons go through the high energy to level to low energy level, but there is a no forbidden gap. So the electron when go through the high energy level to low energy level, the current fastly moving, even we can't control it. So the conductor are not useful in many applications of electronics, right? But yes, we can use a semiconductor material for light emitting diode. Why we use? Because there is a small forbidden gap between the valence band and conduction band, right? And it is around 1 electron volt. We know that the semiconductor materials, there is the third and the fifth group of the materials which is used in a semiconductor, right? And which is used in the PN junction diode, right? For example, silicon, graphite, germanium. Okay, so this is just the image of the light emitting diode. Yes, we know that because we use in the day to day life. Okay, okay, but one of the most important thing is LEDs only just use in forward bias condition. Yes. Why? Because LED emits either visible light or infrared light when it is in a forward bias, right? So the LEDs which emit invisible infrared light we use in the remote controls. Okay, so it is an optical semiconductor devices that convert electrical energy into light energy, right? Okay, so the when LEDs in the forward bias, there are the free electrons in the conduction band which recombines with the holes in the valence band, and it is emit some of the energy, right? Or emitted photons, and we use in the light emitting diode. See, listen, this is the diagram of the layers of the LEDs. This is the P type of semiconductor, this is the N type of semiconductor, and in between there is a depletion region. Yes, we know that in PN junction diode, depletion region, which is the most probable thing, right, in the LEDs. Okay, or sorry, in the PN junction diode, right? We know that P type of materials which contain more holes than the electrons, right? And the N type of materials which contain electrons higher than the holes, right? It means when we apply some of the outside source or voltage, the P type of materials of holes which is attract towards the negative supply of the source, right? And at that time, N type of electrons which is attract towards the positive supply of voltage or source, right? So in between they are here, the recombination of the free electrons or holes which is present in the depletion region, and they emitted some of the light, or we can say emitted photons, right? This is the process of light emitting diode. Okay, when In the conduction band, this is the conduction band, right? And this is the electron. This is the symbol of electron. This is the symbol of holes, and this is the arrow which represent the photon, which is emitted photon. Okay, so when the electrons in the conduction band, which is go through the valence band and it is recombined with the holes, they emit some of the energy, and which is the photons or emitted light. Okay. Okay, so there is the energy loss of the free electrons or intensity, we can say, right, of light depends on the forbidden gap. Yes, forbidden gap, it is the most probable thing in a semiconductor materials, right? Because it is the difference between the energy gap between the conduction band and the valence band, right? So if the semiconductor device with the large forbidden gap which emits the high intensity of light, and we know, and whereas the semiconductor device is the small forbidden gap which emits a low intensity of light. In other words, we can say that the brightness of emitted light, it is depends on the forbidden gap. Yes, if we know the high brightness of LED, yes, we can use the material which have the large forbidden gap. Okay, but yes, some of the semiconductor materials, for example, silicon and germanium, which is not used in the LEDs. Why? Because they have, which is because they release some of the energy in the form of light. So the emitted light, which is very small, and it we can't use in the many application. Yes. So we collect some of the compound materials like galvanium arsenide, galvanium phosphide, which is emitted some of the photons have this sufficient energy to produce the intense visible light. Okay, the next one is galvanium nitride, which is emitted a bright blue light, and the next one is gallium arsenide, which emit the red and infrared light, while indium galvanium nitride blue emit the blue light and the white light. But one of the question is that why you use the direct band gap semiconductor materials in the light emitting diode? Yes, there is the question, right? Because in the direct band gap semiconductor have electrons and holes have some of the vectors in the lattice vibration which have the same momentum, right? So corresponding the conduction band and valence band, right, which is recombined with the holes and electron, right? So these have the same momentum, so which is a emit light in the visible spectrum. Yes, because LED, which is used in the visible spectrum of light, right, which is used in the visible light. Okay, so generally we use the direct band gap semiconductor in light emitting diode. See here, this is the light emitting diode of symbol, and the blue arrows which is represent that the light is emitted from the P and N junction of diode. Okay, now here, the biasing of LEDs is which is a most probable thing. Why? Because generally LED use some of the low voltage source. It's not provide. It's not contain the high energy of the power supply, right? So the energy efficiency is very good for LED. Okay, so the forward voltage around rating 1 to 3 volt, and the forward current ratings like a 200 milliampere, 200 milliampere, right? But if we here we see that the Vs we apply some of the source voltage. If the voltage is high, then the LED which is broke down. Yes. So before we conclude that, we have to put some of the RS, that means a resistor which is in the series of LED. So sudden rise of current, it may do not destroy the devices, right? Okay, So this is the current flowing mathematical represent of the LED. This is the IF. It means the forward current. This is the VS, this, which source voltage we applied like a outside source, right? This is the VT, which is a voltage drop across the LED, right? This is the RS, which use in the series of the LEDs, and this is a resistor. Yes, okay. Yes, there are the many advantage and disadvantage of LEDs. Yes, but pros are very high than the cons of LED. Okay, first of all, first one is energy efficiency, right? We do not require some of the high power supply for the LED. Okay, so the energy efficiency is very good. Okay, extended life. It means we can use in the long period of life. I mean, years to years, we use the LEDs. Okay, the next one is cold temperature operation. I mean, it is useful in the cold temperature also. Okay, and the durability of the LEDs is very good because it is not easily broken. Okay, which is also in keep a switching speed is very high, so it is also instant on, instant off. So the rapid cycling also be very good. Okay, we can control like a voltage because the drop voltage of LEDs very less, right, compared to the outside source. So the controllability is very good for LED. And yes, LED is not harmful for human and the atmosphere also because it is not emitted infrared or ultraviolet emissions, right? Okay, so yes, the disadvantage of LED is also be there, yes, and it is a temperature dependence. I mean, it is used LED is used in the cold temperature, but when the heat is very high around the around the atmosphere, there is some of the thermal management properties also be there in the PN junction diode. So the LEDs is do not work in the temperature in the environment when the temperature is very high. Okay. Yes. The next one is voltage sensitivity when we apply some of the voltage but above some of the threshold voltage the current which will be good will be decreases, so we can't get some of the current, so the electrons can't emit a good photons, right? So LED is not work properly, right? So the so the intensity of light for the LED is very low. So it is not useful when the voltage applied above the threshold voltage, right? And the next one is, and the last is efficiency drop. Yes, the efficiency of LED decreases as the electric current increases. Yes, when the efficiency is decreased, so the electric current increases. So the if in the heating also be increases with the high current. We know that when the electric current increases suddenly, so the heating also be possible in a many applications. Yes, so the lifetime of LED which is very less at that condition. Okay, so we can't use a high power application. Yes, and thank you so much to listening to me and my topic and thanking you.